Welcome, everyone, to this explainer. I'm absolutely thrilled to have you here today. If you've ever stared at a massive, overwhelming wall of code and just felt completely lost, well, you're in exactly the right place. Today, our main goal is to demystify Python functions. By the time we wrap up this explainer, you're going to see functions not as some confusing technical jargon, but really as your own personal mini-factories. We're going to take all that chaos and transform it into order using the sheer power of structured logic.
Okay, so here's our coding toolkit for today. We are covering 1. The magic of functions. 2. Library versus user-defined. 3. Creating user-defined functions. 4. Parameters and arguments. And finally, 5. Local versus global scope. Let's get right into it.
Part 1. The magic of functions. Let's see how we go from total chaos to perfect order by solving the really fundamental problem of repetitive programming.
Be honest with me here. Are you tired of writing the exact same chunk of code twice, or, 3 times? 50 times? When you're just copying and pasting code over and over again, you end up creating what we call spaghetti code. It's a tangled, highly redundant mess. Because think about it, if you find a bug in one place, you literally have to hunt it down in every single spot you pasted that text. It is an absolute nightmare. But thankfully, there is a seriously elegant solution.
Enter the function. Now, you might hear these called procedures or subroutines in other languages, but whatever you call them, they are your ultimate organizational saviors. Their absolute superpower is reusability. You write the code once, and you can call it anytime. You never have to write it from scratch again. And naturally, this boosts your code's readability. It makes your program tell a much clearer, logical story. Plus, debugging, it becomes an absolute breeze. When an error pops up, you trace it back to one specific block of code and fix it right then and there. Ultimately, dividing a massive program up into smaller, efficient modules shrinks your overall code size and really speeds up development. It even lets entire teams of programmers divide and conquer different parts of the software at the exact same time. It's a real game changer.
Moving on to Part 2, Library versus User-Defined Functions. There are really two main types of functions at your disposal when working in Python.
First up, we've got library functions. These are the built-in, out-of-the-box tools Python just hands to you. The code is already written. All you do is import the module and use it with the proper syntax. So think of calculating a square root using the math module's sqrt, finding the minimum or maximum values with min and max, or getting a length with len. In contrast to that, we have user-defined functions. These are your DIY tools. They're the programmed routines you define yourself right at the time you're actually writing the program. You build these to save time and space for specific tasks that are totally unique to your own software.
All right, Part 3, Creating User-Defined Functions. Let's actually start building the blueprint for our custom mini-factory.
So, creating a user-defined function follows a very strict anatomy. You always, and I mean always, begin with the keyword def, which is short for define. You follow that with a valid Python identifier as your function name, and then a set of parentheses. Now, crucially, you cap that header line off with a colon. That colon is what tells Python, hey, instructions are coming up next. Then comes the body, which is your actual algorithm, and it absolutely must be indented. Anything unindented is just completely ignored by the function. Finally, you use a return statement to send your calculated result back to the main program. Actually, a quick side note on that. If you omit the return statement, your function will just quietly return the value none. But remember, writing out this anatomy is really just drawing the blueprint. It doesn't actually run the code yet.
So let's put that blueprint into action. Say we have a definition, def add x, y. The indented code inside it calculates z equals x plus y and then returns z. But down below that, on an unindented line, we have s equals add 70, 50. That is the actual function call. When Python reads that exact line, control transfers instantly right into the function. It does the math, and it stores the answer in s. So printing s gives us a sum of 120. Our blueprint is officially alive.
Which brings us to Part 4, Parameters and Arguments. In that last example, we used letters like x and y and numbers like 70 and 50. Let's demystify exactly what those are.
Let's tackle parameters first. Parameters are the variables listed within the parentheses while you are designing the function. In our def add x, y example, x and y are the formal parameters. Think of them as the placeholders, the receiving slots in our mini-factory.
They dictate exactly what type and how many expected values the function absolutely needs to receive in order to do its job properly.
Arguments, on the flip side, are the actual values passed into the function when it is called. So when we wrote add 70, 50, the 70 and 50 were the actual parameters, also known as the arguments. These are the actual, tangible, raw materials you feed into the machine when you finally press start. These arguments fill the parameters during execution, giving the function the real data it needs to compute a result. And an argument can be a hard-coded constant, a variable, or even a complex mathematical expression. It's super flexible.
Okay, part 5, local versus global scope. We've built our functions, we've fed them arguments, but to write truly bug-free code, we have to know exactly where our variables live.
And this brings us to scope, which basically determines where your variables can actually be seen by the rest of the program. Let's look at local variables first. These are declared inside a specific function block. They are highly protective, they can only be accessed within that specific function. We use them for temporary calculations, and listen, this is the key part. Their value is utterly destroyed the second the program flows out of that function. Conversely, global variables are declared outside of any function. They have a much broader scope and are accessible across all the modules and functions in your entire program.
Let's look at a quick run. We define a function called xmm. Inside, we declare local variables x equals 10 and y equals 20. We add them to create z and print the sum right there inside the function block. So when we call xmm at the bottom, the output displays exactly what we expect. The sum is 30. And this works perfectly. Why? Because all the calculations and the printing happen entirely inside the function, where x, y, and z are perfectly alive and well.
But now, let's mix these scopes up. Right at the very top of our script, before any function is even defined, we declare a global variable, y equals 100. Then, inside our xfunc function, we declare a local variable, x equals 10. When it comes time to calculate z equals x plus y, the local function actually looks outside, pulls in that global 100, and adds it to the local 10. The result? A sum of 110. Global variables are incredibly powerful because they act as these shared resources for your whole script.
However, be warned, misunderstanding scope causes some really severe errors. Say we define xm with local variables x and y. We call a function to run its hidden math, but then on the very last line of the script, completely outside of that function, we ask Python to print x. What happens? We get a traceback name error stating that the name x is not defined. Why did this happen? Because x was a local variable. The exact moment the xm function finished, x was destroyed. To the global program trying to print it, x literally does not exist anymore.
Which brings us to the ultimate puzzle of Python functions. If local variables disappear like smoke the second a function finishes its job, how do we bridge that gap? How might you effectively use that return statement we talked about earlier to rescue the important results from your Minifactory and pass them safely back out into the global world of your program? Think about how data needs to flow to make your code both modular and connected. I really want you to experiment with this in your own code today. Thank you so much for exploring the structural magic of Python functions with me, and definitely keep learning.